Hi guys, this video is to help you work your way through homework day 8. I apologize that I'm not there, but hopefully this will give you enough insight so you know what your work should look like. So from the video you watched last night, if you're given an equation and points on that equation, what we're going to do is take each point and create an equation where we filled in the x's and y's from it. So let me just copy each of these down. All right. So remember, each point is an xy. We're plugging on in here. So the -1 goes on the left, a times 1 squared, b times 1, and then plus c. So that is going to turn into -1. This will just give you plain old 1a plus 1b plus 1c. Now you can put the ones in or not. That's totally up to you. I don't care. All right, the next one, same thing. We're going 23 and then equals a times 3 squared plus b times 3 and then plus c. So this will give you 23 and then equals 9a, 3b, and plus 1c. And then the last one, put 7 on the left. If we plug a -1 in, we plug, a -1 here and here. We would get 7 and then equals 1a minus 1b and then plus 1c. So there is our system of equations. So for these guys, I'm going to label them. So here I'm just going to say equation. Maybe I'll go with 1, 2, and 3 instead of a, b, and c, since we have a, b, and c's in here. All right. To me, the easiest thing to go after are the c's, because they have all the same coefficient attached to them. They're just all positive. So what we want to make sure to do is as we bring it down, we're going to actually negate, right, the value and kind of go from there. So in this case, if I take equation 1 and I negate equation 2 and then add them together, that'll knock the c on out. So I'm going to do equation 1 and then plus a negative of equation 2. All right. So let me copy it as is. So I got -1 equals a plus b plus c. And then the second equation I'm negating. So it'd be -23, -9a, -3b, and -c. All right. Add this stuff together. That'll give me -24, 1 minus 9, so -8a. This is 1 minus 3, so -2b, and those guys go. All right. I'm going to circle that equation in red. That is one of my 2 equations that I'm going to get that have the 2 variables. Do the same thing again. I'm just going to pair up the next 2 because it's easy. So you have to negate one of them. It doesn't matter which. Given that I already negated number 2, I might as well just keep it. So it's -23 and then -9a, -3b, -1c. And then I'm just going to copy equation 3 down. So 7, this is 1a minus 1b plus 1c. All right, the whole point of doing this, the c's are going to go. We'll be left with everything else. So if we have -23 and then plus 7, oh, that's hurting my brain right now. That should give us, what, -16, and then -8a and -4b. All right. So here's my lovely little system of 2 equations and 2 unknowns. I'm going to grab a calculator really quick because I forgot to grab that. What's nice about what I've got going on here is that I have a -8a and another -8a. I'm just going to flip one of those so that I get one as +8a and keep the other one negative. So I'm going to leave this one alone. So -24 equals -8a minus 2b. And as I bring this one down, I'm going to multiply it by -1. All right. So that'll make it +16, +8a, +4b. Let's add those guys together. So right here, this should give me -8. This cancels. This gives me 2b. And then if we go through and divide, this is going to give me b equals -4. So there's my first solution. Stick with that 2 by 2. Plug back into one of my red circled equations to figure out a. So I'll just go to the first one here. If I plug in my negative 4 for b there. Here's negative 8a plus 8. Subtract that over. That's going to give me negative 32. Divide by negative 4, and a will come out to be positive 4. All right, 2 variables down, 1 more to go. Go back to one of the original equations. So I'm just going to go to the first one. So the first one was negative 1 equals 1 times a plus 1 times b plus 1 times c. Well, this would give me 4 minus 4 plus c equals negative 1. That just knocks out c has to be equal to negative 1 there. All right. You can either check by plugging into one of the other equations, or in this case, finish the question. So it says find the equation in the form of ax squared plus bx plus c. If I plug in, this should be 4x squared minus 4x and then minus 1. I'm going to check this way. If I take and on the calculator, slide this underneath here, try to slide this up a little bit so you guys can see. If I put in 4x squared and then minus 4x and minus 1, I can go and either graph it or go right to the table and look for those values. So when I say those values, I mean the points they gave us back here. So the point 1, negative 1 should be on here. So there's 1, negative 1. And then 323, there's that guy. And I skipped it, negative 1, 7 right there. Right? So that's the way to check my answer. First one's done. Flip it on over to the back. The way that this one is worded sometimes can mess with people a little bit. So it's saying Mr. Laley's shopping for new school clothes. He's another one of our Algebra 2 teachers. He needs to buy an equal number of shirts as ties. He also needs to buy 4 times as many shirts as pants. All right. So it's saying shirts cost 35, ties cost 25, pants cost 40. We want to do a little let statement action over here. So to keep things easy, I'm going to say let S equal, the number of shirts. Let's let T equal the number of ties. And let P equal the number of pants that he's going to purchase here. Right? So it's saying he needs to buy an equal number of shirts and ties. So that first statement right there gives us an equation. So an equal number of shirts and ties. So that means that S equals T. He needs to buy 4 times as many shirts as pants. So that does not mean we're just going to do 4 times S equals P. It's saying 4 times as many shirts as pants. So he has way more shirts than he has pants. So in that case, what that means is that you're going to have to take, you're going to have to take the number of pants that he has and multiply it by 4 to equal the number of shirts that he has. That's what this statement right here is giving us. Okay? The last part comes in with the cost. Based on that, hopefully that seems kind of easy. So for every shirt, it's 35 bucks. So 35 times S, and then plus for every tie, it's 25 bucks. And the last part, for every pair of pants, it's 40. All of that together is going to equal, oops, hold on one second. I don't know what that's doing. Okay. Am I still there? Yes, I am still here. All right. So we're going to add all that together, and that's 560. Now, you can set this one up just like we did and do elimination, but it's a little bit easier if we maybe get everything in terms of one variable. So if we move so that everything is in terms of one variable here, we know that since S and T are the same, anywhere that there's an S, you could plug a T in or vice versa. The fact that S is equal to 4P, this is kind of the variable that's connecting everything. So I'd like to get everything in terms of S. All right, so wherever there's a T, let's put an S in place of it. Oops. So this would be 25 times S. This already is an S, so let's keep it. 35S. And then in place of P, I'm going to put S in place. So every 4 P's equal to S. Well, that's a little weird. Let's just take this and rearrange it. If I divide it by 4, P is going to be equal to S divided by 4. That's what I'm going to plug in place of this guy. So in place of 40, put in S divided by 4. All right, if I clean this up, we have 35S plus 25S. Here, remember, we've talked about this. 40S divided by 4, that would give us 10S, and then equals 560. If the S is messing with you, just call it an X, all right? That would be fine as well. Otherwise, let's use the calculator here. If we go 35 plus 25 plus 10, that'll give us 70. S equals 560, and then divide that on out. So 560 divided by 70, the number of shirts that he needs is going to be 8. So there should be 8 shirts. Same number of ties, so 8 ties. And then the number of pants, we're going to take the shirts and divide it by 4. So if we do 8 and divide it by 4, you only need 2 pairs of pants. All right, keep in mind, you could have rearranged, written this all in T, written it all in P. There's multiple ways to do it. This isn't the only way. Last one is the most straightforward. What I want you to look at is what's the easiest way to tackle it and go from there. So this one in particular, I actually would almost argue that it's just as easy to get rid of the Y's as it is the X's. I would say the Z's is maybe the only one where you'd have to do extra work. But given that the Y's have the exact same number in the front, my thought would be let's eliminate the Y's. To me, that's like the absolute easiest. So I'm going to call this A, call this B, call this C, or 1, 2, and 3 would be fine, right? But right now, I can pair up the first two, and they are ready to go to cancel out the Y's. So over here, if I do A plus B, that's going to give me X plus 3Y plus Z equals 3. And then 2X minus 3Y plus 2Z equals 3. Make sure you add up all the terms. So this gives me 3X, this goes, that gives me 3Z, and 3 plus 3 gives me 6. There's my equation with 2 variables. So let's get rid of the Y's again. I'm going to combine the the second and the third, because those will naturally cancel out again. So if I go B and C, add those guys together. All right. This will give me 1X. Those go. This will give me minus Z. And then 3 and 1 together gives me 4. Once I get it down to a little 2x2 system, my entire focus is just on solving that system. So to get these to cancel out, you could either multiply this equation by -3 to cancel the x's, or by just +3 to cancel the z's. I think I'm going to just multiply it by a +3. All right, so the first equation stays as is. Second equation, that would give me plain old 3x minus 3z, and then 12. And then let's add those guys together. So this will give us 6x. This would cancel. This gives me 18 divided by 6. It does not have to be a whole number, but a whole number is a good sign. If it's not going to be a whole number, it better be a pretty fraction here. All right. But x equals 3 is looking good. Stay with this little 2x2 system and plug back in. So let's say if I plug into that first equation, 3 times 3 plus 3z equals 6. So 9 plus 3z equals 6. Subtract that 9 on over. Divide. So there's my z value. It's another nice one. Last thing, plug back into one of the originals. I only have space left over here, so I'm going to plug back into the first equation. So into A, I've got my x value. I don't know y. I do know z. I now start cleaning it up. So 3 minus 1 would be 2. Subtract 2. And then divide by 3 here. All right, now I have a fraction, but 1/3. That's not a bad fraction, so before we panic, let's check. Okay. So the check, pick one of the other equations to plug into. I'm going to pick B, because why the heck not? All right, if we go 2 times x minus 3 times 1/3 plus 2 times -1, it needs to come out as 3. You can absolutely type that whole left side in on the calculator if you want. So 2 times 3 minus 3 times 1/3, and then plus 2 times -1. That comes out perfectly to equal 3, which is what we want, which means it checks. So if this is good, then that's our final answer. So the way we would write it for a question like this is just as an XYZ point. So X goes first, Y goes second, Z goes last. That is the final answer to this question. I hope that helped. Feel free to pause, fast forward, rewind, whatever you need to do to get yourself through those homework practice questions. All right, I'll see you guys tomorrow.